Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about what are the different types of graph representations. So what is a graph actually? So a graph consists of finite set of ordered pairs, what we call as an edges of certain entities, what we call as the edges also called as arcs or links, and the vertices also called as nodes or points. So a graph is a finite set of ordered pairs called as edges, and V should be the set of vertices, what we call as vertices. And the other synonyms what we can able to call is arcs and edges. Edges is that, so arcs is the one synonym and links is also another synonym. And vertices is also called as nodes, or I can able to call it as points as well. So if I'm going to draw a graph, so in that graph I can able to represent vertices. So this should be the vertices, and this one what we call it as edges. So the other synonym of edges what we call it as arcs, or maybe to call it as links. The other synonyms for vertices is that nodes, or maybe to call it as points. Normally, a graph can be represented as a G equal to V comma I, where V should be the set of vertices and E should be edges. So a graph is a set of vertices and edges, and a vertex may represent a state or condition, while the edge may represent a relationship between the two vertices. So a vertex may be that it should be a state, or it may be a condition. Well, the edge may represent a relationship between the two vertices. So in this one, this should be the graph. So it should be the vertex, and this should be the edge, and this should be the weight. So what are different types of representations? So there are two ways out there for representing a graph in memory. So first one is sequential representation, and another one is linked list representation. So what is sequential representation? So here the graphs can be represented through a matrix in system's memory. So they should be in sequential in nature, and that's why this kind of representation what we call as a sequential representation of graphs. So if I'm going to have a graph like this, so whenever there is an edge from A to B, so this should be called as edge. So normally this one is going to be stored in system memory, so in the form of a matrix. So whatever the edges are there, that one I'm going to construct, and whenever there is an edge, I can mark it as 1, and B to D, B to C, D to B, and D to C, C to B, and C to D. So remaining all should be zeros since there is no edge here. So some other types of representations will be circuit adjacency matrix representation and incidence matrix representation, circuit matrix representation, cut set matrix representation, and path matrix representation. So these are other kind of representations of the graph. So in this one, the first one is adjacency matrix representation and incident matrix representation, circuit matrix representation, cut set matrix representation, and path matrix representation. So when I'm going to consider this, so I have to be follow this kind of representations here. So what is this linked list representation? So here the graph can be represented through linked list in system memory. Sure, this should be linked in later. So normally this kind of representation is called linked list representation of graph. Suppose if I'm going to have a graph like this, so how I can able to represent this in linked list form? So for that, first I have to present a node C and E. So for A, what are the edges that are connected? So A to B and A to C. And so for B, it should be B to E and B to A. So B to A and B to B. And for C, C to A and C to D. And for D, it should be D to E and D to C. So these are the various types of representations, linked list representations of a graph here. So normally they should be linked in nature where the nodes are going to be connected on means of pointers, and this kind of representation what we call as linked list representation of graph. There are different types of representation. First one is adjacency matrix representation. So what is this adjacency matrix representation? So it should be a matrix of the graph with of n vertices of the size n by n. So it is going to be given by a equal to a of I. So this a of I should be 1 whenever the two vertices are adjacent, and it should be equal to 0 whenever the two vertices are not adjacent. So if I'm going to consider a graph, so the edge should be 1 whenever the matrix value should be 1 whenever there is an edge. That means the A and B are adjacent, and B and D are not adjacent, and B and C are not adjacent, and A and C are adjacent, and C and D are adjacent. So what I'm going to say is, so take a adjacency list, adjacency matrix, and mark it should be 1, 0. There is an edge from A to C since A and C are adjacent, and similarly from B to A, 1, B to C being otherwise remaining all 0, and C to A, C to D, 0, and D to C, 1. So like this, the values are going to be represented. They have a value. So this value should be 1 if it should be the two vertices are adjacent. It should be 0 if two other vertices are not adjacent. And next one example is that, so take a graph like this. So in this graph, So what are the edges? So A, B, C, D, E, F. And similarly, I'm going to note it as A, B, C, D, E, F. So how this should be one? So D to E. So there is an edge from D to E, that's why it should be one. How these values are assigned? E to B. So this edge. So that's why it should be one. So why it should be 0? F to C. So F to C there is no edge, so that's why it should be 0. And similarly F to E also 0. It is not going to have any kind of edge. Some other presentations of the graph. So how I'm going to represent it? So take a graph like this. This should be the vertices and this should be the edges. So remember 1, 2, 3, 4. 1, 2, 3, 4. So I have an edge from 1 to 4, that's why it should be 1. And similarly I have an edge from 2 to 4, that should be 1. And 3 to 4 should be also 1. And 4 from 1 to 3 as well. And this should be the corresponding adjacency matrix of the given. What is this incidence matrix representation? So this incidence matrix of a graph G with n vertices and E edges is given by n into A. So this m value should be 1 if it is incident to V, otherwise it should be 0. The incident matrix of G with n vertices and I edges is given by this one. And so whenever this one should be 1, so if there is E edge is incident on VI, otherwise it should be 0. So let us consider this. I'm going to consider the set of vertices here. I'm going to consider set of edges here. So here I have an edge from 1, so that's why it should be 1. And 1 to E2 is there, yeah. And 1 to E3 is also there, that should be 1. And it should be 0 since there is no edge from E4 from 1, so that's why it should be 0. And similarly, if I'm going to consider 3, so the 3 I'm going to have E2 1 and E4 1, so remaining all are zeros. So like this, we're going to represent the incident matrix whenever there is an edge from V to E. Next one is circuit matrix representation. So it is represented by the number of different circuits T and the number of different edges should be the T into E, and the matrix is going to be given by C is equal to Cij. So that should be 0, otherwise if it should be 1 if the circuit is going to be indulged JH. So consider a graph and consider the set of vertices and edges. In circuit 1, so what are the edges I'm going to have? So that should be E1 into E3. And circuit C2, I'm going to have the edges like E1, E3, E4, E5. And circuit C3, it should be 0. So like this, we're going to be represent the circuit matrix by using graphs here. So based on the edges. So what is next one is cut set matrix representation. So the matrix S is equal to S of J I rows corresponding to the sets, and the columns are going to be respond to the edges of the graph and is going to be defined as cut set matrix. So it should be 1 if there is a cut set contains JH, it should be 0 otherwise. So in this, the cut set matrix, the rows corresponding to the cut sets and columns corresponding to the edges here, and what we called as cut set. And here it should be 1 whenever there is a cut set contain the edge, otherwise it should be 0. So consider a graph. So consider the set of vertices along the y-axis and set of edges along the x-axis. So I have an edge from V1 to V3, so that's why it should be E4. And for 2, what are the sets? E1 and E2. And for 3, what are the sets? E2, E3, and E4, that should be E1, E2, and then E3. So the cut is nothing but a vertex, and edge set is nothing but an edge. So what is this path matrix representation? So the path matrix is generally defined as specific pair of vertices. Then the path matrix is going to be denoted as U, V equal to P of I. And this P of I should be 1 if there is an edge in the path ij. Otherwise it should be 0. So example, so we have 16 volt. So it should be consider the set of edges and set of vertices along the x-axis and set of edges along the y-axis. And is this one, so whenever there is an edge, so E1, E2 and E3, so I have edge from E2, E3 and E4. And similarly I have 2, so what are the edges? So V1, V2, V3. And next one is adjacency list representation. So this adjacency list representation is one of the alternative to the adjacent matrix, and it requires the less amount of memory. And for every vertex, the adjacency list is going to store the list of vertices which are adjacent to one another. So this adjacency list should be the one of the alternative adjacency matrix. So why? Because it is going to be require less amount of memory, and for every vertex, the adjacency list is going to be stored set of vertices. So example, I'm going to consider. So what is the adjacency list here? So what is the adjacency list for 1 is only 4, and 2 it should be 4 and 5, and 4 it should be 2 and 6, and 3 it should be 3. So in the form of adjacency list, so what are the vertices are there that should be listed out here, and from that we have to be represent what are the nodes of vertices that are connected to. So that should be 6, 5, 1, and then 2. And for 4 or so it should be vertices is 1 and 2. And here in this one, if I'm going to consider this, then I can able to get nothing here. So in computers, there is a many mathematical represents are there. So the adjacency matrix and adjacency list are commonly used for representing the graphs in computer. So what is this? Dense graphs and sparse graphs. So dense graph is the graph with minimum number of edges that should be closer to the maximum number of edges. And the graph with only the few edges is called sparse matrix. So the graph which minimum number of edges that should be close to the maximum number of edges. So that's why it should be a dense graph. Otherwise, it should be considered as sparse graph. So some of the examples of the graph is that like this. And sparse graph means so it should not belongs to SPT. It does not belongs to sparse matrix. So here what I'm going to say is, so in this graph it should be the half connected, it should not be fully connected. And here what I'm going to say is that in this one, so I'm have to consider the edges of different fashions. That should be space graph. Dense graph means that each and every edge that should be fully connected to the all other vertices. So dense graph means there should be in your inside and other subgraph of on that graph. And this is the under subgraph of the graph, and this should be under subgraph of the graph. So this and all we consider as dense graph. So the dense graph is the one which is going to have a minimum number of edges that should be close to maximum number of edges, and quite opposite that should be the sparse graph. What are the advantages of this adjacency matrix? So it is very convenient to do to work with, and you can also add and remove the edge in one time. At the same time, it is going to be required to check whether there is an edge between the two vertices. So adjacency matrix is quite convenient to work with, and you should also easily to add and remove edge whenever there is an edge between the two vertices. When it comes to disadvantages, so the adjacency matrix is going to be consume huge amount of memory for storing big graph, and this adjacency matrix requires huge efforts for adding and removing the vertex. And many algorithms you need to know that edges are adjacent to current vertex to draw out such information. An advantage is that so the adjacency list is going to allow to store the graph in more compact form than adjacency matrix, and this adjacency list is going to be allowed to get the list of adjacency matrix, which is a big advantage of some algorithms. And disadvantage, so adding and removing edge is too difficult from adjacency list, so it is not easy for our adjacent matrix. And here it requires only the average of E by E, so which may able to represent the typical complexity of dense matrix of all edges. So if there is an edge between the two vertices, then when the list of adjacents are ordered, then it should be treated as like that. So the adjacency list does not allow to make an efficient implementation, and if the dynamic change of vertices is number is required, then adding the new vertex can be done, but removal results that will be estimate of complexity. So finally, I conclude that the adjacency matrix is good for dense matrix or dense graph, and also good for the space graph, and also for changing number of nodes. So like these are the some of the types of representations of the graph here. So in this one, so the graph is nothing but a set of vertices and edges, and how we're going to be represented is that so it should be represented as set of v comma e. So where v should be a set of vertices and edges, and there are two types of representation: sequential and linked list representation. So sequential means we are able to represent the graph in the form of a matrix, and linked list means we should be able to represent in by making use of linked list. So these are some other representations of the graph: adjacency matrix, incident, circuit, matrix, and path matrix. So in the linked list, the graph is going to be connected by means of linked list, and an adjacency matrix is a 2 by 2 matrix, so which is going to contain only zeros and ones. And incidence matrix is the graph with the n vertices is defined as n into e, which is going to be mapped along the number of vertices and number of edges here. And circuit matrix is represented by number of different circuits and number of edges, which should be the product of t into e. And here also we are going to map this along vertices along the wedges, and use the whatever edges present that should be marked as a circuit here. And cut set is nothing but so here the cuts is going to consider as vertex and rows, and then edge is going to be considered as columns, and it should be one whenever the edge contains. And path matrix is the one which is where whenever there is an edge from B to I, and adjacency based matrix is the one which is going to have alternative adjacency matrix, and for every matrix it should be going to be stored in list of matrices. So there are two types of dense matrix and sparse matrix, sparse graphs. So the dense graph is the one which is going to have the minimum number of edges closer to maximum number of edges, and quite opposite is the sparse graph. So these are the representation of dense and sparse graph. And advantages of linked list is to the graph more compact form, and the disadvantage is that adding and removing is quite simple, quite not easy when compared to adjacency matrix. and adding an edge is also that much easy here. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.